In this video, we are going to discuss about design work procedure in piping design. So first we have to understand what is the significance of design work procedure. It is nothing but a set of procedures which needs to be followed in any piping design projects. However, it varies a little bit from project to project, but predominantly in a overall view, if you look at it, the systematic flow of these procedures remains same in most of the projects. So first important thing is that we should understand this conceptually. So that's very important because if you don't understand this procedure, then you will really find hard while executing your actual piping design work in a real project. You will be able to get an opportunity to learn pipes, pipe fittings, valves, and many things about it. But I believe that there are very less materials available in order to tell you what is design work procedure is known as. So in this video, let's take this opportunity to understand what it is. So I am going to share about a very simple procedure which can be generally used and followed in the brownfield engineering. And it varies a little bit in the greenfield project that I will cover in a different video. But however, let me try to share you the actual work process, the design procedure which is generally used in the brownfield engineering. So we are going to start from here. At first, as a piping design engineer, when you initiate any piping design project in brownfield engineering, the first and foremost thing that you will receive is the scope of work document from client. What is the scope of work document? It is nothing but the requirements of the client based on which you will have to design the piping design output. It is not only for piping. Scope of work, it defines the project. So it is integrated work to be done from all the disciplines, and piping will also be a part of this project to deliver the piping outputs. So the scope of work will give you the idea about what is the project, and it will show you the schematic, like if how many number of equipments involved, what are the major lines. So it will tell you the schematic of the project that you are going to work. Then further the process engineers will develop that. We will come to the next stage. So from scope of work as a piping design engineer, your responsibility is to try to understand what is actually to be done from the piping point of view. How many equipments are available, how many lines are available, whether these lines are insulated or not, whether these lines are the size of the lines are bigger or not. So how many drain lines are available, how many valves are available. Try to get as many informations as possible, though the informations will be very minimal at the very initial stage of the project in the scope of work. So once you get this information, your responsibility is to pull out the respective layouts like a plot plan or piping layouts and do a conceptual study. That's the second stage. See, at this stage, you will not have a P&ID, you will not have line list, nothing, but still you will have to do it just a conceptual and feasibility purpose. Only then you will be able to understand where exactly you're working, which point in the layout that you're going to work. How many, if in case of equipments, whether you will be able to place the equipments or not, whether the space is available or not. So you will get an overall idea about the project, and also you will have a lot of clarifications if the scope is not in a position to be implemented in the particular layout. So you will go back to the client to ask clarifications. However, the second stage, the intent of the second stage is to study the scope of work in the with reference to the existing piping layout or plot plan or whatever it is, to understand and see the feasibility of the implementation. That's very clear. So scope of work is done, then the second conceptual study is done. So by this time, process engineers will develop the P&ID. They will start extracting inputs from the process point of view from the clients. They will develop a lot of calculations by which they will generate the inputs, and they will be able to frame the exact P&ID with line size and everything. So the next stage is that you will receive a P&ID. P&ID with the preliminary P&ID with the preliminary line informations and equipment details and everything. Along with that, You will receive an equipment data sheet if equipment is involved or not. So the first and foremost thing after getting this input from process is you will have to see how many equipments are involved, whether these equipments with respect to its own size, you will be able to place it in the drawing or not. So now, do you understand the difference? Initially, you have done the conceptual study. So in the conceptual study, you will be able to understand whether the space is available or not. Now, you're going to get the exact data sheet with the exact equipment size and I mean the size and nozzle connections and number of nozzles and height and everything. So from the moment you get this information, your mind will directly tell you whether it is feasible or not. However, you will have to place the exact equipment sizes in the plot plan and finalize the equipment location. So the third important stage after the conceptual study, after getting the P&IDs and process inputs, your duty is to finalize the equipment location. So where do you finalize the equipment location is in the plot plan. Okay. So you simply cannot put it somewhere in, which has no relation with the project. Actually, you will have to see the most feasible option to place an equipment by which you will be able to achieve the process requirements. It should be safe and it should be the installation should have a feasibility of maintenance and constructability. All these parameters you will analyze and you will finalize the location. So the intent is to finalize the location in the plot plan. So once you finalize the location in the plot plan, then you will have to take an approval from the client. This information needs to be discussed with the respective the client counterpart, your piping design leads, and as well as you will have to ensure whether from operation construction point of view there is no issues for this particular equipment, because if your equipment location goes wrong, then everything will goes wrong. So it's really important to take as many reviews as possible, at least in order to finalize the equipments, because that is the fundamental origin point of your piping. You imagine if your origin point is not finalized, then how will you finalize the piping? So this is the foremost third step. So scope of work done, conceptual study done, and you receive the P&ID and process inputs, and based on which you finalize the equipment. So along with the process inputs, you are also getting the P&IDs and line list, right? So from the line list, you will be able to see how many number of lines and whether it is stream traced or insulated, what is the temperature, pressure, and everything. So once you get the line list, first and foremost thing for you to finalize the material, you will have to choose the right spec, right pipe spec. I hope that you understand what is pipe spec is all about. Otherwise, you can watch my previous video. In a simple note, pipe spec is a document that lists out all the necessary piping materials to be used for a particular service. So you will have to determine the pipe spec. Generally, most of the clients will have a lot of pipe specs with respect to different pressure and temperature. You have to choose it. In case if there is an issue with the material selection, like pipe spec selection, then you will have to refer with the material and corrosion team in order to finalize the piping material, and based on which you will choose the piping spec. So the next important step is that choosing the piping spec with respect to the process input you have received from P&ID, line list, and the inputs which are available in the line list. So once this is done, then now you will have to really work on your line routing. Line routing in the piping layout or in the 3D model. If you are using the 3D model, you can develop the line routing in the 3D model. If you are using the piping layout, then you will be using the 2D drawing in order to develop the 3D, line routing. So imagine that you have a bunch of lines in the project. So you have to start by one, then you have to streamline with the second one, then third, and then fourth one. So finalizing one line routing doesn't mean that you have finalized every line routing, because when you finalize one line, then you will be thinking only from that particular perspective of that particular line, right? But when it comes to a layout, you have to organize the line. You have to ensure that accessibility, maintenance, operability are available for all the lines. So layouting planning is very important. That is why we generally call there are piping layout specialists who are actually good in developing this layouting. You must be good in routing, but layouting planning is different. Layouting planning is nothing but how to minimize the usage of space in the piping layout, so that with a limited space usage you will be able to accommodate all the lines. So that's very important. So the predominantly what I'm trying to say is that the layout planning, the sense the grouping of the line in such a way that it is designed in a way that the most of the spaces will still be available for future expansions or future use. So this is the next important thing that you have to do it actually. So once you develop, this is all a preliminary stage only. So by this time, see how it works, and you receive the P&ID and you finalize the equipments and you're doing the piping layout studies and everything. And by this time, the process would have done lot of other calculations and finalized the process part completely. So once the process parts are completely done, then there is something known as design review to be done. You know what is design review is about? Design review is nothing but a session where you will find a facilitator who is going to completely go through your design parts, especially from process point of view, and little bit about mechanical and piping point of view. So they will have to review everything, and not only the facilitator, you will find a process leads from the client side and mechanical leads from the client side and safety engineers, and all discipline heads will be there. They will go through your design completely, basically a review from the process point of view. So, and predominantly from the layouting point of view, these reviews will be done, and the intention is that whether the design is meeting the requirement what client has actually came up with. Okay, so that's the primary intention of it. So once design review is done, during the design review they will find something which has been already missed in the project, so you will get an action. So they will point out some of the corrections to be done, so those corrections are taken as an actions, action 1, action 2, action 3. So then you will have to work on this actions. So this is predominantly of the process actions, but there are something where you will get a mechanical actions also in terms of what do you call additional lines, or in terms of introducing a new valve. So mechanical also will have to integrate with process, or you will have some major the equipment placement issue or underground issue, something like that. Okay, so you will have to keep this in your mind in such a way that during the design review you will get multiple actions. So all these actions as a project, you will have to comply. You will have to find the solutions and produce the actions to the client in such a way that to get an approval. So once design review and their actions are done, imagine that this is an overall activity, not only for piping, even process engineer, piping, material, and as well as civil also will get an action. So once this collective actions are done, then you will move to the next stage. Next stage is you will have to, as a piping design engineer, you will have to release the MTO, because your design is done, your design review is done. Once design review is done, the first thing that you have to do is that release the MTO, release the preliminary MTO. This is known to be the preliminary MTO. Why is it so? Because at this stage you are 100% sure that there will not be any changes in the design. Only changes that is going to come, it is because of your layouting. In case of some additional elbows are required, in additional vent points are required, so additional drain lines are required, so that is different actually. That may come during the development of the project, but predominantly what has been from the process side discussed has been finalized. So MTO can be released from piping point of view. Okay, so after the design review, piping MTO, preliminary MTO will be released. And now you will, once the design review is done, you will still have to go back to your layout and finalize the routing, because initially you have done the conceptual. Then once you receive the P&ID, you have done some study about how to finalize the routing, but it is not finalized. But once DR is done, then you have to finalize your routing and try to find there is no issues in the accessibility, maintenance, or operations. In case if you find any issues with the accessibility, maintenance, or operations, then you will have to bring to the notice attention of your leads, and if they are not able to solve, then it has to go to the respective client's lead. Then they will think about the better solutions. Maybe if they wanted to reduce the line size or increase the line size and extend the line to a different locations, all these factors will be discussed. But the intention is, But the intention is once after the design review, you will be in a position to finalize your pipe routing so that you will be able to list out all the corrective actions to be done in the line routing and layouting. Not only line routing, layouting. Because when I talk about line routing, it is only a routing. But when I talk about layouting, it is about supports and grouping and utilization of the space and accessibility, maintenance and everything. Okay. So this is the stage you have already finalized your layout. I would say generally it is somewhere around 80 to 90% you have finalized it. So now, since DR is done, I mean design review is done, actions are closed and your MTO released and your piping layouts are done. So the next important stage after the action closeout of the design review and developing the piping layout is to go for the hazard review. Hazard review is something like hazard and operability study. So generally during the hazard and operability study, they will review everything which can lead to an hazard, right from the pressure point of view, temperature point of view, accessibility point of view, support point of view, and I mean human factor engineering point of view, safety point of view, everything will be discussed. And once again, the entire project will be reviewed, and in terms of hazard actually, not in terms of design, because design is already covered in the design review. Now they will only review the hazard point of view. So from the hazard point of view also, you will find your leads will be appearing in the workshop. You will find the facilitator going through all the parameters which I've just said now. So they will find the respective actions, corrective actions, and for which also you will have to work on in order to improvise your design. So once hazard is done, you can imagine that your 90% design of your project is done, because there is no complexity further actually, provided the actions of hazard needs to be finalized. Now what you have to do, you will have to finalize your layouts and 3D modeling and everything. So here the one thing I wanted to say is about the process of reviewing the 3D modeling, because 2D will be a different and 3D will be different. In 3D modeling, there is something known as 3D reviews also there. Generally, 30% 3D modeling review will be done after the DR. And once 30% review is done, again you will find a lot of actions in the design review. Those actions you have to correct it in terms of routing, maybe supports or accessibility or safety point of view. And then the 60% review will be done after hazard. That is what I wanted to point out here, because now you have done with the hazard. So once after the hazard, after completing the hazard action, after correcting the hazard actions, then you will move to the 60% model review. Once 60% model review is done, which means that your model is almost finalized actually, then you will do the final 90% review after incorporating all comments, which is right from the interdisciplinary comments or vendor inputs, whatever vendor inputs are pending, those things you will finalize and go for the 90% design review. So once 90% 3D model design review, because not the process design review, what I'm saying, because process design review already completed. Then we went down for 30% model review. You will go for 60% model review. Once 60% model review is done, after capturing all comments, you will move to the 90% model review. Once 90% model review is done, then you are almost in a position to release your AFC. So AFC will be prepared, engineering package will be delivered. But in order to deliver the engineering package from piping point of view, you need to have the AFC document for process. So process will release the AFC document, AFC approved for construction, PFS will be there. And based on the PFS, you will finalize the piping layouts and routings or 3D model, and you will ensure that there is no further change, and you will start producing isometrics. So they start producing the final MTOs and final support drawings. And in case of any changes that needs to be finalized before the AFC itself, because AFC is something which is known as the final one. So once 90% 3D model is done, you will finally release the AFC package. During this AFC package, even if there are some inputs are still missing, you will keep that information as whole and release the AFC with hold package. It could be of layout or isometrics or something, because there are some vendor drawings you still may not would not have received, so you will have to keep that information in hold. So AFC withhold will go. So once the vendor information is received, you will have to revise those drawings and send the final AFC, which is it will go into the next revision, and you will release the final MTU. So this is the kind of process that you have to do for follow for any brownfield projects in the piping design. It may vary little bit in greenfield projects that I will cover in the other particular video, but this is how it goes actually. Once you understand this process conceptually, that you will be able to clearly drive your mind accordingly, because most of the people don't understand where it starts and where it ends actually. So during this entire process, you will have to discuss with the other disciplines, and you will have to check for the different inputs that you have to receive in order to finalize your inputs. So generally, we in real projects, we used to have a lot of coordinations. We used to maintain a good relationship with the respective engineers, so that we will also get the informations on time. So that's very important actually. So I will meet you in another fantastic video, guys. I hope this video will really give you an idea about what is the simple design work procedure generally being followed in the brownfield engineering. I'll meet you in another fantastic video. Until then, bye from Subhash Chandra.